Alright, so here we are with classifying triangles for chapter 4. We are going to classify by angles and then also side lengths. So there are two different ways to name a triangle, so we just want to be clear about which is which. We're also going to use triangle classification to find angle measures and side lengths, and so we will be using some of our ideas from the previous chapter. For this, there are actually going to be a lot of definitions that you're going to be using and that you can put into your reasons packet. We'll take the time in the assignment video to fill in the reasons packet, but these definitions will be available to packet. Sorry, I muted myself for a second. Alright, so here we are with our first triangle classification, and this is where you might get out your protractor, the one that kind of looks like this, has little lines all along it. The idea here would be that you could put the vertex at this open space that's here, then there's this line that goes off, and you'd put that along one of the edges of the triangle, and then the side would go out to one of these angles outside here. Now, of course, on your protractor there are actually two measurements that you'd get, and hopefully we know that as we look at this one it is less than 90 degrees, and so you would not pick the one that says like 150 or something. You would actually pick the one that was less than that. And so as you kind of take a look at that, or just identify that this is kind of the size of a right angle and what we have here is definitely smaller than that, we're going to classify this one as acute. So acute triangles have 3 acute angles, okay? So we do want to note that that's different than an obtuse triangle, for instance, which we'll get to, but an acute triangle has 3 acute angles. They don't necessarily have to be the same measurement. They can be 3 acute things, whatever they happen to be. An interesting part about triangles as well is that they sum to 180. So every single triangle that you have is going to have a sum of 180 degrees. So no matter what, for instance, those two angle measures are, if you take that away from 180, you'll get the missing angle. So this next one here is indicating that each of these angles are the same measure. And it turns out that they are also acute as well, but this is a special type of acute triangle, which is an equiangular triangle. But again, it is also acute because, as I mentioned before, remember there's 180 degrees inside of this triangle. If we divide that by 3, we get 60 degrees. So every single one of these angles is 60 degrees if they're all supposed to be the same. And so they're 3 congruent angles. And it can never be any other measurement other than 60. The next one here is what we're going to call a right triangle. Hopefully you can see that right angle measurement in the corner there. So right triangle, of course, has a 90 degrees in it. And then because the fact that everything else adds to 180, we also have then 2 other angles that have to be acute, otherwise they won't add to 180. So again, 1 right angle. The interesting part about the definitions is that some people will think, because of the previous, that we have 3 right angles, but that is not possible to make a triangle with 3 right angles. So 1 right angle. The other one that I mentioned before is an acute triangle. So here we are with an acute angle. And how do you know it's, obtuse angle? If you actually drew a square kind of in this corner, the idea would be that this is going out past that square, or that right angle. So again, just as we're looking at it, there is 1 obtuse angle, again, because you can't have 3 obtuse angles, things over 90, that add to 180. That's not possible. So for instance, 91, 91, and 91 could be 3 obtuse angles, but if you add that all up, it is definitely going to be greater than 180 degrees, which is not possible in a triangle. Alright, so another thing to note is when you look at a figure, you cannot assume segments are congruent based on appearance. So as much as I draw 2 lines that literally look exactly the same, unless they have a congruent marking on them, you cannot say that they are the same. So as I look at, for instance, this equiangular triangle, I cannot say that this side length is equal to this side length unless, of course, it's mentioned. we will actually go to a definition that helps us with that. So, taking a look at our sides, because again now we're naming things by the sides lengths. If you have all of the same sides, instead of equiangular, this is what we call equilateral. Lat meaning side. So, equilateral triangle says there are 3 congruent sides, and that's going to make your name via lengths. We also have an isosceles triangle. As you can see, 2 of these sides are the same length, and so that goes with isosceles. Turns out isosceles is a word that I tend to forget a lot of, so I have to pause most of the time to remember what I'm trying to think of. So notice it says at least 2 congruent sides, and so it turns out that this previous one is isosceles as well. Wait, there's no extra C in there. Just because of that definition, so at least 2. Well, it could be 3 then. Alright, this next one here looks like an obtuse triangle, but remember we're doing it by side lengths and not by angles. And so in this one we're actually getting a scalene triangle, so no congruent sides, meaning all 3 sides have a different length, whatever that may be. Alright, so these are supposed to be angle images here. Okay, so a little quiz or review on what we need to know here. Each triangle is going to have a sum of 120 degrees, and we're going to classify them by its angles. So this is actually supposed to be an image of a triangle. Triangle MNQ and NQP and MNP. Alright. So taking a look at triangle MNQ, that's this one here. It says we want to classify by its angles and its sides. So if we look at all of its sides, notice they're all 6. So in that case, we can call it equilateral. Another thing that we can do is find out what the angle measures are going to be. So if we take a look at, for instance, this line that makes up 180 degrees, if it's cut and this piece is 120, 180 minus 120 leaves you a 60 for this angle measure. Let's see how else I can do the next one. I also know that because these are all the same length, it turns out that any equilateral triangle is also an equiangular triangle. And so it turns out that this is 60 and this is 60 as well. So all equilateral and all equiangular are the same. Equiangular. And then we also have back here, equiangular is also equilateral. So it's given every time. Alright, NQP, so looking at our next triangle, N to Q to P, so that's this obtuse triangle over here. And how do I know it's obtuse? Because it has one obtuse angle. So we're going to call it an obtuse triangle based on its angles. And then based on its sides, we have an 8.1 side length, a 6 length, and a 3.2. So that's when we call it scalene, because all sides are different. Alright, then the last triangle we're trying to look at is MNP, so that's this larger triangle. And from our previous triangle, we know this degree is 60. This over here is 40, and then this one up here is going to be 20 plus 60, so 80 degrees. Just double checking that that does make a triangle. 80 plus 40 plus 60 is 180, so those are the degree measures of those angles. And so taking a look at those are all less than 90 degrees, so we're going to call this an acute triangle. And looking at the side lengths, we have 8.1, 6, and 9.2, so we'll call that scalene as well. Alright, the next piece that we are going to do is looking at the idea of an isosceles triangle. So notice that this is isosceles. Oh, I'm really into putting an extra C in isosceles today. And again, we know that it's isosceles because of these two pieces here, which means that those two sides are equal, or those two expressions are equal. So 3x plus 2 is going to equal 4x minus 7. We can use that to find x, and then we can plug it in. So if we use that to find x, I'm going to subtract a 2 over here, which will leave me with negative 9 and a 4x. And then I'm going to subtract a 4x over to both sides, which means that I'll have negative 1x equal to negative 9. Or if we divide everything by that multiplier, we're going to get an x of 9. Now that we know that x is 9, we can plug it back in up here for the x, so 3 times 9 plus 2. We also have 4 times 9 minus 7, and even though this side down here is not equal, the x is still the same variable, so 2 times 9 plus 5 will get us that measurement as well. So these two numbers, whatever the math is, will end up actually being the same, so we should get, what is that, 36 minus 7 is 29. And 3 times 9 is 27 plus 2 is 29. So those two side lengths are 29, and then this last one here is 18 plus 5, or 23. Alright, so those are a few of the pieces that you should have got from our notes today. So kind of going back to the objectives here, we wanted to classify triangles by their angle measures. Okay, so things like acute, obtuse, and right. And then we also have side lengths, and so that's going to be things like scalene or isosceles. And then use those triangle classifications to find angle measures. So remember that since we know something's isosceles, or since we know something is equiangular, whatever it may be, there are equal pieces that we can then use to solve. Taking a look at our vocabulary again, you're going to want to be able to identify each of these pieces. And we will be putting them in the reasons packet. And then also that idea that triangles have 180 degrees inside of them.